Right. Good afternoon, everyone, and welcome to our CAWASA Wednesday webinar. And this afternoon, we're going to have with us Dr. SAAD JASIM, who is not new to us. He's presented to us previously. So we'll get right going. We had some glitches, so I'm going to share the screen now so that you can get going. All right. Share. Right. Over to you.
Okay, thank you.
Dr.
It says you started screen sharing, Ignatius, but I don't see the actual. Oh, here we are. Got it.
Yeah.
You're
Okay.
not seeing it?
Yeah, it's
Can we see a full screen?
Oh, you're not getting the full screen? Okay,
Or
let
it's
me.
only half of it. Yeah.
Okay, let me take that again. Just a second. I gotta go to the. So, I have to go to the. Share. Okay, that's it. Can you see it now?
not yet.
Not yet.
Oh, why is
There,
that?
there you
Yeah.
go. It's still half of the screen, but
Halfway only.
Oh, sorry. Yeah, I think it's because it's PDF. So, okay,
yeah.
let me fix
Maybe if
that.
we reduce the size,
Yeah,
if you reduce the size to 80%.
yeah. How's it there?
Yeah,
That
it's
looks
better
good.
now. Yeah, it's better now.
All right. Okay.
Or
Good.
maybe even more. Yeah, it's slightly up, slightly down. That's the title page. Yeah. No.
Or you mean the title page?
Yeah.
Okay.
Yeah, the
All right.
subtitle page is Climate Change Impact on Water Sources. So we're going to be talking today about this, and thank you all for your interest. This is a topic that impacts everybody who works in the water industry. And it is a serious event, climate change. And if we don't plan for things to happen, because by the time there's a problem, it takes a while to recover. Next slide, please.
All right.
I think in PDF you may just have to scroll down, Ignatius.
Yeah, scroll down.
Yeah.
Yeah, that's what it is. Okay.
Yeah.
Okay.
So water and climate change, water is connecting to almost everything. It is the medium for all our activities, and it's impacting and connecting the ecosystem. And it has an important thing about the sustainability of societies. All civilization created around water. And we've seen recently in the last few years higher temperatures, extreme weather conditions because of the temperature impacting on rainfall, snowmelt, river flows, and all these things, which will impact water quantity and quality, which is a big issue. Slide down, please. Yeah. And as we see here, according to the Water Meteorology Organization 2026, the global mean sea level has increased by 11 centimeters compared to 1993 in about 30 years. And it is going to be more increasing because of the snowmelt. And that's going to impact groundwater, salinization, flooding, and others. And also the glacier mass loss, it is the worst on record compared to what used to be a few years before. Next one, please. And most of the disasters are water related. Flooding is impacting many parts of the world now. and we see landslides, storms. Many nice areas now having problems, even, and I've seen it on TV in some countries. The insurance company do not insure houses right on the by the sea because of the landslides, which is a major issue. And this, what we see here in the pictures, used to be regular areas, but it became a flooding things, and that would cause a degradation of the environment, and also the impact on sanitation, because when you see it this way, that means your sewage treatment plant has been compromised, your drinking water plant has been compromised because of this flooding. And that takes a while to recover, would cause some waterborne diseases outbreaks. Next one, please. In Latin America and in the Caribbean, floods has been happening, and we've seen it in many of the locations, especially in Brazil in 2024 and 23, and they had 683 millimeters of rainfall in 15 hours. That caused 65 deaths and a flooding of the whole community in that region. Next one, please. And that doesn't happen only in that region. In Canada, this is Toronto in 2017. And they have to go by boats to get people from that train that's stuck in the water. And imagine the situation, people coming back from work, they get stuck in a lake of water, and rubber boats came to save them. And that's only 9 years ago. Next one, please. And going back, I try always to share this. In 2014, the 17 goals, and goal number 6 was to ensure availability and sustainable management of water and sanitation for all. And when you have disasters like that, you lose control unless a better planning for human resources, infrastructure, and others. Next one, please. And what you see in this diagram, and you see here, those are the 17 goals established by United Nations, and they are all connected to water. See in the middle. This is number 6, the water, and you see the dark ones are the one directly connected, like life below water, effect on land, human health. All these things are seriously connected, and the others are connected as well. And you see, these are some kind of agreements, like climate change in Paris, the Sendai framework in Japan, and also the Sustainable Development Goals to achieve by 2030 agenda. Next one, please. And the link of water, health, sanitation, of course, environment, ecosystem, energy and low carbon development, agriculture, and human settlement. Again, when you have desert in the area or a contaminated area, water quality is bad and contaminated, people do not go there. Next one, please. Linking water, energy, and climate. The talk has always been there, and you see titles, water and energy nexus, and climate change, and all that. But unfortunately, we've seen, and I said it a few times, I sit on many groups, and when they talk climate change, it's energy and how you save on energy. Water has been ignored. And I'm one of the people who have been pushing for that. Even I wrote to United Nations about that, because even their conferences lacked the talk about water. Next one, please. What you see here, this is a diagram, shows the increase in temperatures, and you see it's a serious increase. This one is about 24, 23, and you see the level compared to years. And now, in fact, 24 and 25, we exceeded the 1.5 level. And they were one of the warmest years, 24 and 25. So we are exceeded this challenge that is, we are still supposed to be doing that. That means countries are not doing what they are supposed to be doing. Next one, please. And talking about the lack of talk about energy, about water, just about energy, going to the United Nations conferences, and I'm talking from the COP27, which was in 23. Egypt. That's the first one they start talking about water.
Oh, yeah. And we've been talking with the girl that I'm working with.
And there is a need to prioritize that. So the talk was to consider that for COP28. So impact of water quality, because people many times talking about quantity only, but water quality is a big issue because it's a human health impact and also agriculture and others. So you need to focus on that. And that a serious discussion started on that. Next one, please. And the in 2028, it was in Dubai, they start talking about seriously the water, I would say the second year, more seriously. And they're talking about the countries that need involved. And Dubai is one of the areas that suffer from water scarcity, and it's impacting their agriculture. Most of the food they get is delivered by by flights every day. So when you have now the current situation, it's a problem because when there's no flights, the airport is shut down. That's a problem on the food storage, and how often they have some fresh food. So this is an important thing. And if there is a framework developed by the United Nations about the climate change framework, and indicated that you need to have some serious planning and for these countries. Next one, please. And the year after that, for the COP30, which was a 25, I think 25 was, and there was some better movement, and they established some guideline and indicators, 59 indicators to follow for like water supply, sanitation, and the impact of climate change on that. So this position, that means these services, that means you establish some resilience for globally, the United Nations, the countries involved, develop that. And this will address water scarcity, flooding, and also impact on agriculture and others. Next one, please. But the unfortunate thing, when you have these things in the United Nations, these things are voluntary. It's not accountable if they don't do it, the countries. And there's no impact on, for example, the investment that the IMF or the World Bank do if they don't do that. So these goals are hopefully to be implemented, the 59 goals, and that will drive the well-being for these countries, and also it will align the governance arrangements and with some of the data foundations sustained to attend in that. So these things you need to follow up and all that, and hopefully a better framework is developed and get practiced. Next one, please. Water scarcity. that is one of the big issues. There are many locations in the world that they have this problem, and the UNICEF has been addressing these issues and identifying the countries. The World Bank is doing the same thing, identifying that. And also, these countries are encouraged to develop certain practices, and they have to think outside the box. It's not like we did it like that in the last 10 years, we do it again. So the next one, please. So that was a study done on impact of drought on water quality. When you have a drought, that means less water. So when you have chemicals, for example, the chemicals of major concern, pharmaceuticals, endocrine disruptors, when you have less water and the same discharge from sewage treatment plants, and that means you have a higher concentration of these contaminants in water. And that diagram shows, the in Lake Mead in Las Vegas, the study was done. The water level went down dramatically because of the lack of rain, and it was because it's a man-made. So, and also the overuse of water. They used to have like mist, water mist in the streets to make the visitors, life easier because temperature is warm. So that means the concentration has been increased dramatically. Next one. And this is developed by the World Bank, and it shows the water stresses around the world. And you see many countries have different kind of water stress. It could be a shortage, or it could be flooding, and also could be even with the groundwater, if there's any arsenic or other compounds in the water from groundwater that could be impacting that. And believe it or not, this is a problem people used to ignore before. And I've been in some sites that they drink that water with arsenic and manganese for 70, 80 years until we build up a water plant for them. And you see all kinds of diseases people have. Arsenic, manganese. Manganese, they found that it impacts the brain development for children, the IQ. So people have different kind of impact of water on health, on agriculture availability, on the population. But the problem is some locations, like, they establish some kind of systems, like, for example, desalination, if you have enough fresh water or rivers. But this thing as well, some of the discharge of the minerals, the brine, into the source water increased the salinity of that water, source water, and pushed some of the fish and mammals away. So this is a problem, because you're changing the ecosystem structure here, and you see in many of the areas around the world suffering from different of these stresses. Next one, please. And because of the drought, you see also fires, and we have it in Canada, United States, other places, Africa, and others. And it is a problem. And the problem, and you see here the impact on the conductivity in water because of precipitation of ashes and all that, the turbidity increases, and also the loss of the agriculture, the green lands loss. It's reduced the impact, or has an impact on the ecosystem, because the CO2 issue used to absorb it for that, and so it is a problem, when you have that. And we've been, like in Canada, United States, they've been suffering from that for years. Every year it's happening. And I was talking one time with one of the politicians. I said, for God's sake, people sending spaceships to the moon, and they can't put off fires. That doesn't make sense. I've been in North America for over 30 years, and every year is the same thing. And but people have different interests. Next one, please. So with the I remember one time during the fires in the summertime, it was indicated there is not enough water to supply the firefighters to get rid of that. And that's why you need to look at an alternative. You look at water reuse, because the thing is, we use about, for example, when you do drinking water, and I've been involved in that, and I know these things, less than 10% is used for drinking. About 70% is for agriculture and others for other domestic uses. You need to consider that wastewater discharged, and many times they discharge it to the river, even after treatment. So the reuse of treated sewage effluent is an important source of water. And I'll give you an example. What is happening now in the condition in the Middle East? Some of the desalination systems being hit. But if you have a water reuse on the sewage treatment plants and you develop a storage for that, you have a source. You still have water for firefighting, you have water for agriculture, and you have some of the other clean water for drinking. And that is how you need to think and to have alternatives. And you have to look at new technologies. It's not like when you use something all the time. And ozone, I talk about it because I tried it for 30 years for different reasons, and it works. And you see some countries been using it for more than a century. Do we know that? Did many people know that the first drinking water plant, drinking water, was in Nice, France in 1906? 1906. And they're still using that because it works. Next one, please. We need to look at the water reuse seriously, and we need to look at, because it's a large source of water to be considered because of that. Because people are talking about, water from the air, humidity, all this. Sewage treatment plants discharge a huge amount. Billions of gallons goes into the rivers and the lakes. So if you retreat that, you use that. Golf courses, they are all over the place. And they use the treated water that's used for drinking. And the other thing as well, treated water has chlorine in it. This is not good for agriculture. So the treated sewage effluent still have some organics, but then when you do a reuse for that, you remove those and make it more healthy for the agriculture and even for drinking. And it is used for drinking in Singapore, and they received awards on that. And they have bottles, they sell it, they call it new water. And so it works. So it depends on the culture, understanding. You could use it for many, many things. Next one, please. And this is the highest stress, water scarcity area in the world, according to the World Bank. And you see that's the red, that's the hottest areas. And I worked in some of these areas. Temperature exceeds 50 centigrade in the shade for a couple of months in the summertime. And winters are like 15 degrees, 20 degrees. That's winter. So it's hot. So there's a need to use a lot of water. So agriculture, it is demanding 70% or more needed in that region. Next one, please. Water reuse, of course, has risks. For example, you have to have some intensive treatment because you have potential pesticides, solvents, pathogens. Pathogens is the biggest issue here. Heavy metals, nutrients, and chemical emerging concern. Because sewage treatment plants have water coming from hospitals, sewage, all that the human being use a lot of pharmaceuticals. Hospitals discharge a lot of pharmaceuticals, and many of the products used for to treat people. So that's why you need to have some advanced systems to do it. But the thing is, some studies showed that when they were comparing it to talking about some regions, they compared it as slightly less energy than desalination. Because when you use reverse osmosis and others, this is high energy. And also, you need to consider, especially the warm areas, we have a lot of sunshine, sunlight, use some solar energy. You reduce the demand on the fuel that you use for other purposes. Next one, please. We developed this system, a pilot system. I designed it when I was working in Qatar, and it is patented. And this one treated sewage effluent into water suitable for use, agriculture, cooling towers, domestic use. For example, you use it in your washrooms and something like that. And it took 3-4 years to go through in a lot of details, and it's been registered and patent number on it as well. So it's not impossible. It can be done. And you do it, and that process is being followed in different parts of the world now. Next one, please. Change in weather conditions has been impacting us because of the snow melt, the higher flow, and you see streets become like rivers, and that is because the change of temperature, the impact on the humidity in the air, the wind, all these things has been contributing problem, and that ends to the impact on the water quality in drinking water plants, or also for sewage treatment. Because, for example, the disinfection process depends on contact time and concentration. And many of these systems, and we did studies on that, they don't have the capability of adjusting to sudden changes like this. And especially if you're using certain technologies that has a limited impact, you have to have the water is slightly clean. And so if you have heavy water coming through, you will have and I've seen it in sewage treatment plants during a storm, water is coming dark brown into the river. That means disinfectant is almost gone. So you have to think seriously about what technologies you use for these things. Next one, please. And again, for the discharge of sewage treatment plant, the sewage treatment plant is the biggest source or a giant collector of human activities. Also, you have one of the other things like laundry discharges. Laundry, they clean dirty clothes. So dirty clothes has everything in it, from human issues or other domestic things, oil from work. People work in certain industry, they come and wash it. Where does that go? That go into the sewage treatment plant. And sewage treatment plants are not designed to remove these chemicals. And also, when you have that heavy rain coming like this, the demand increase. So the system is not capable of doing it if you don't use certain technologies. Next one, please. This is a sewage treatment plant in Houston, Texas. That's in 2019. And you see it's flooded. And if anybody been to Houston, Houston is a big city. So any flooding like this, that contaminated the city as well. Next one, please. And people say, so why we are concerned about it flooded or not? Well, these chemicals, even in small concentrations, these are bioaccumulative, what we call the chemicals of emerging concern. And it has what we call endocrine disruptors. And I talked about that in details in the previous one. but it's all connected because those impact the design of the system. If you don't design your system to deal with these chemicals, especially you don't design your system for when the water is weather is beautiful. I collected samples because I was looking at potential change in design. I collected samples in the river and the intake when there is a storm, when there's heavy rain. And I've seen most of sewage treatment plants are upstream from the drinking water treatment plant intakes. So when you collect that, you see hundreds of GRD and cryptosporidium in 100 liters. And this is, you should have zero. So it depends on the filtration only. And that could be a problem as well. Next one, please. One other issue is heavily connected with the climate change is the cyanobacteria, harmful algal blooms, and that's created by a lot of sunlight and also nutrients in water. And the combination of that, and also if the water is more still, that's why you see it's more by the shores, because the water speed is very limited. That's why increase. And what it does, it consumes a lot of the oxygen, so you have a lot of fish kills, and we've seen it in many locations, and also impacts the drinking water plants as well, and will cause economic problems because it impacts the fish industry. If they depends on fish, and suddenly thousands of fish die, people are concerned, and because it could be toxins, it could be hypoxia. Next one, please. These are some of these algal blooms, and you see Sundospermopsis or Plantothrax gardi, and there are many different things, but those are quite common, and you see them, and then they have impacts on health. Next one, please. And this is about the fish kill because of the hypoxia. All the oxygen is gone, so the fish floating. I remember one time I was driving on a highway which is kilometers away, and I smell the dead fish, from about at least 10, 15 kilometers. It's bad because the wind brings you all that. Imagine people living close by because it's near the lake, nice houses. Imagine when you have that pile of fish, dead fish, near your house. It is a problem. And also, there are toxins produced by these things, not just taking the oxygen, but the toxins produced, which we call them, it's known as the cyanotoxins. Next one. One of the tides are known as the red tide, and it happens in different places, Florida, the Middle East, different places. And it's caused by certain material called the Carenia reefs algae. And this is also produce neurotoxin. What is neurotoxin? These toxins impact the nervous system for the human beings and cause to be paralyzed and die. So these toxins also can be suspended in the air near the beaches and cause a human respiratory illness. And they can also accumulate in shellfish and cause neurotoxic shellfish poisoning. So that's why you need these states to look closely at these problems and to monitor this situation and to give certain guideline or banning on use of that. And can we go down slightly, a little bit on the slide, slightly more? Yeah. So the neurotoxics, this is a big issue here in that. Next slide, please. That's also red tide here. Next one, please. And this is in the Middle East and Oman. That's where We hear it all the time, the Strait of Hormuz. That's exactly there. Next one, please. And you see here the fish die because of this toxin. Next one, please. And this is in Florida, in south of Florida, this kind of algae. And you see the impact. You have the boats and all that, and nice area. You're supposed to be sitting there. You wouldn't be when you have this kind of situation. Next one, please. The Gulf of Mexico experienced a lot of a variety of these problems from the harmful algal blooms. So the shellfish harvesting caused certain diarrhea, called diuretic shellfish poisoning. In Florida, there's the amnestic shellfish poisoning, and there's the recreational of fish banned in some areas in Florida because of that, called the saxitoxins. Saxitoxins is that produce impact the nerve system, and what they call the ciguataria fish poisoning that could be issued in South Florida and some parts in Texas as well, and produced by the Gammioreducus, which is a type of organism associated with the microalgae on coral reefs. Next one, please. And that's the Gulf of Mexico in 2019. Next one, please. And that's green is the algae. That's satellite picture. And the next one, please. This is like red tide in San Diego, offshore San Diego in California in 2017. So back to these cyanotoxins. These cyanotoxins are in cells. So that is what we call as an intracellular toxin. But when the membrane of this cell is ruptured, this one is released, and that's what they call the extracellular toxin. And the rupture could be natural; the cell dies, and the membrane gets ruptured, breaks, or by an impact, like for example, movement of boats, or when it comes in the drinking water plants or sewage treatment, and there's a mixer that could break these shells and release the toxins. And that impacts the recreational water and the drinking water as well. And you could have many of these cyanotoxins. And some of these toxins are, if we go further down, please, next slide, the microcystins, cindospermopsin, and toxin A. And the reason I'm bringing those three, those are being found more regularly than others. Next slide, please. So the impact on water treatment plants. The water treatments are impacted because it will cause the filters to be plugged. You do more filter backwash, so there's more wastewater. Also could increase the chemical demand because could produce, you need more for the disinfection, so could produce disinfection byproducts, and that's another problem to be created. Next slide, please. Well, the efficiency, as we said, the removal depends on the system, how it's designed, of course. So after what happened in Toledo, the EPA developed a management system. If we look at it here, the next slide, basically need a proper monitoring for your water source to see any potential, is it vulnerable, is any discharges from agriculture or others, and and you need to look at, then you develop certain plans to deal with that. You need to do some treatment adjustment, change in the flow, if you have any additional plan to reduce the pressure on the system, and if you have certain technologies to be considered, especially if you are doing some infrastructure upgrade, you need to look into that. So this diagram shows a good plan to look into that. Monitoring is an important thing, should lead into some decisions to take a system to deal with that. Next one, please. So I'm going to give an example here on the Great Lakes, an incident that happened. And in 2014, microsystems were detected in the finished water, treated water for drinking in the city of Toledo, Ohio. Toledo, Ohio is close to 500,000 people and exceeded the guideline, which is 1 microgram per liter, which is in fact way more than that. So immediately they put a ban on water use, and they start to deliver bottled water to the public. And delivering public bottled water, because this one you can't use water for drinking, cooking, or even this kind of water you can't use it even for showering. And so that many water, that's a major cost. And also the staff their work was delivering, like even the staff who work behind the desk came down to help the city delivering bottled water. So a study started, a pilot study to look at what kind of treatment, and they considered the use of ozone for water treatment to remove these toxins. And it is known that is the best way. So if you go next slide, please. And this is the Great Lakes, that location, and that we see on the left side, that's a heavy green, and that is where that on the left side at the end, that's where the city of Toledo, and that is what the impact on that. And you see on the top the lake at the upper level, that's what they call Lake St. Clair, and this one, the big lake, this is Lake Erie, and this is the shallowest in the Great Lakes, the 5 lakes. And the amount of the algae was quite heavy. That's in 2014, the year of the outbreak. Next slide, please. That's how the water was coming to the city. It's like a smoothie, but nobody will drink that, of course. And you see here the staff are delivering bottled water to the public. That was August 11, 2014. Next one, please. And that is the situation in the lakes is not changing, because still there is a lot of agricultural activities in the area. And it was, the study shows that the DNA for these nutrients found was from fertilizers in Lake Erie. And you see it's still the same after 6 years. Further, please, the next one. So we developed a study in the city of Windsor with the university. I developed that study to look at the 3 toxins that were found the highest concentrations in Toledo and Lake Erie. So the microcystin LR and cylinder spermopsin and a toxin A. Those are the 3 I mentioned them earlier. And you see the structure, a very complicated structure for each one of them. Next one, please. And you see the impact. The first 2, microcystin and cylinder spermopsin, impact the liver and cause abdominal pain, vomiting, both of them, and they cause death. The third one, the toxin A, impact the nervous system and cause tingling, burning, numbness, and all that, and would cause people to be paralyzed and die. So the United States issued that outline in 2014, the EPA. Next one, please. So they issued a temporary guideline for each one of them. They used to be only microcystin. Then they issued this temporarily for those. And then a few years later got changed as well. But that was immediately after the impact of the outbreak in 2014. So they included the age of people. Why the age? Because infants, the immune system is still developing. And adults have a better immune system. They can. So the children, they should have the lowest amount to get this thing. Next one, please. So we did a study on this. We looked at ozone and ozone-based advanced oxidation system. Next one, please. This is oxygen with energy you put into it. You make ozone. O2 change it into O3. One atom connects to the other molecule of oxygen, become ozone, which is O3. Next one, please. And it's also developed in nature. Even with sunlight, UV light, breaks the oxygen and connects with molecules and becomes the ozone molecule. Next one, please. And ozone is a very strong disinfectant. What you see is this diagram. It shows it's about 80 times stronger than chlorine. What do you mean stronger? That has ability to react 80 times faster. And also that means a smaller contactor. If you do chlorine, it has to be 80 times the size of the one for ozone. And that's big. Next one, please. And we use advanced oxidation is by adding hydrogen peroxide. The one in the low level is the hydrogen peroxide. You add it to the ozone, so it becomes advanced oxidation. Next one, please. So the Detroit River study, we looked at it to use ozone and advanced oxidation. And we found in that study that the easiest one to oxidize was microcystin LR, followed by cyanidospermopsin, followed by anatoxin A. And that's in Detroit River. Next one, please. And you see this diagram shows the impact. And we have publications we had in 2020 about that. It shows here the diagram, the impact of ozone. Next one, please. And you see here, and the impact of pH. We've seen that, for example, the anatoxin A, the best pH to impact is the one in the middle. That when you have pH 10, which is not an easy way to do it in a water treatment plant. And the others, like the microcystin LR, no, we found it like low pH is good. 10 is less, in fact, this one. You go to the microcystin, the cyanidospermopsin is the one in the middle, around 7.5, 7.6. They have the best one. But we found that the ozone concentration play a big role into that. And even at low concentrations, ozone was very impactful in removing all these cyanotoxins. Next one, please. We looked at the advanced oxidation. We've seen a removal, but we did not see a major change in the removal. There is a removal, but it's small. When you're talking about when you want to add another industry to remove 1 or 2 nanograms per liter, you have a full industry to do that. A partial of 1 nanogram per liter is not worth it because you wouldn't. It's already oxidized with the ozone. So it shows that it's fine to have this application. Next one, please. So during when we just finished that, in fact, the city of Toledo finished their implementation of ozone, and the mayor of the city of Toledo put that statement. If we can push the slide a little bit up. Yeah, ozone treatment at the Collins Park water treatment plant is another critically important step we have taken towards making it the most efficient and modernized water treatment plant in the nation. It is the most advanced technology available to continue our fight against toxic algal bloom. Algal blooms are a recurring scourge in Lake Erie, and Toledo has adapted to deal with this issue. So at least, they got the right method to deal with that. Next one, please. And this group, NOAA, they monitor the algal bloom in the Great Lakes. And you see here, if we go slightly up, it shows the increase. We haven't seen the level to go below the level of 3. That's what they request. And so it is about 4 or 5 most of the time. And in fact, that's 23, 24, and 25 was the same level as well. Next one, please. So when we did the first research project, we looked at each toxin separately when we are oxidizing. But we need to see the optimum operation because these come all together. So nobody can use 10 pH at the plant, drinking water plant. And 6.5 or 5 is a bit low. So what is the optimum? So we started a new approach to do an advanced oxidation, using the 3 of these toxins together to oxidize them. And the project was funded by the Public Utility, NWIN Utilities, and MITEX, which is one of the groups that funding universities. So we start looking at that, and we look at different pH, different temperatures, and we look at around the year. So it's been going on for a year and a half, and we're anticipating to finish the project by end of August this year. Next one, please. That concludes the presentation, and I'm open to any questions. I've noticed some questions in the chat.
Yes, Prof. There are a few questions in the chat.
Yeah. What are some of disinfection byproducts? Well, when I mentioned byproducts, when you do that, because of these it is organic. So when you add chlorine, for example, you're gonna need to do more chlorine because it's gonna consume it. So that means the current disinfection byproducts of chlorine, THMs, haloacetic acid, others. If you use ozone, it depends if you have high bromide in the water, bromate ion. So you could develop bromate with the oxidation of bromide. So it depends what you have, what kind of system you have. Another question, I think there was another one. Okay. In your opinion, do you think there is possibility in the effect on climate change on the water sector, which leads to scarcity? It can also lead to conflict over water, like we see on oil. Well, I wouldn't be surprised. Water, it's the reason that we live for, because without water we can't live. And I hope we don't reach to that point. That's why I think, looking at water reuse, that will reduce the passion to go into wars because of certain commodity. And if there's any other question, how would you classify toxicity of smaller molecules resulting from oxidation of the larger toxin? Well, put it this way, we're looking at those in nanograms per liter. We're oxidizing it, and no studies has shown that it has an impact. And it will be better, in my personal opinion, that when you have, for example, something that has a bigger quantity, and that's what chemistry and all that is all about. If you have a very low concentration, as I said, nanogram, if I break it into thousands of pieces, it wouldn't have that effect, and it is oxidized. When you oxidize something, that means it's coated. And that's when you oxidize any material is getting coated by the oxidation process. Any other question?
I don't see any others in the chat. Just that I should just mention today that this presentation is quite timely because it speaks to water, climate change and impacts on water sources. And today, coincidentally, is Earth Day. And it is also a day when the Paris Agreement on climate change, if you remember, 1.5 to stay alive,
Yeah.
as was well promoted by the Caribbean region, was presented, was signed onto by, I think, most of the many countries globally. And yet today we're still seeing major shifts away from that and not real commitments to honor,
Unfortunately.
unfortunately so. And of course, the collapse of some of what has been advocated by the Caribbean governments, particularly the Prime Minister of Barbados, on the loss and damage and so on. So we have to keep on promoting the work by the climate scientists, and of course to educate the public about the impact on our water sources. And as you have quite rightly pointed out, some of those impacts and what it can do by the examples you presented on the water resources that are finite.
A couple
So
of years ago, we were trying to get funding to do the project, and it was a struggle. Then we found one, like, I'm not going to say who, which country, where, but they funded $3 million to study the water quality of the lunar water, the water on the moon. And I said, wow, we have all these problems with the water here, and we're studying the water on the moon. Nobody lives there, for God's sake. And they said, oh, you have to look at future. I said, what future? Like, people have to be serious. But the thing is, this bring more, how can I say, lavish talk. Oh, we've been studies, and a mobile unit is going to go on the moon collecting the water samples and ship it to the university to do the analysis. Well, I said, we have all these lakes contaminated and all that. The guidelines are not covering the real problem. And we're looking at the water quality on the moon. $3 million. What can I say? But
yeah,
that doesn't stop us from pushing. I always say never stop. Keep going. Because, we have to keep doing that. Because the thing is, public pressure make the change.
absolutely.
And this is for the cyanotoxins I'm working on. I want to change the guideline. Because when you have other toxins in the water, you cannot have guideline on one. It has to be on the existing ones. We'll see how it goes.
Yeah, and I think you also mentioned, and I wasn't aware of that history of the first new water treatment plant that was ever built was in 1906 in
Yeah,
Nice,
the ozone.
France.
The use of ozone for drinking water was the first one in Nice in 1906. So, and ozone's proved to be successful. Europe is heavily in the use of ozone. North America has been late coming to that from the early 70s or something like that. There are over 300 plants in the US and about 50, 60 plants in Canada, mainly in Quebec, because Quebec has more connections and with France. And Ontario, we put in the first one for primary disinfection and all that in 2001. So it comes in June this year. We have the 25th of anniversary in Windsor. And I'm proud to say that I'm the one who proposed and implemented it in the city of Windsor in 2001.
Yeah, there's another interesting one that you pointed out was to do with the red tides. And
Yes.
then I'm thinking of, is it there any coincidence or maybe historically, even like in the previous era where there's some sea that is the Red Sea, would it have had anything to do with that?
I I'm not sure, to be honest with you.
There's no
Another
such as,
the history of that, because there are names. For example, the Dead Sea. They
yeah.
call the Dead Sea because of the salinity of the. So the names, I don't know why they call certain names. So, but I don't know, to be honest with you.
But
The
certainly
source.
the impact of these algal blooms, I think many of the examples you cited were a lot to do with freshwater lakes. I think there was one, I think, which had to do with one of the oceans. But generally, because we're seeing now in Western Asia with where they depend heavily on desalination systems, what some of the
Uh,
impact would be as a double
In fact,
whammy
in fact,
conflict.
the one I saw in Oman, it
Yeah,
did hit the Gulf, I think about 15 years ago or more, and it shut down the desalination plants.
right.
So it does have a big problem because that algae covers the reverse osmosis units or any other membrane. Even the one they use the thermal desalination. With the thermal thing is by heat. So by heat you generate all kind of compounds and smell and all that, and that cause many problems. But with the
Right.
membranes, definitely it clogged the membranes, in the application. And in fact, the offshore of San Diego is there, that is the ocean, and it is Oman. I did most of the work on that because that's where I am around the Great Lakes area. But it doesn't definitely in the oceans, in different parts of the world, because wherever there's nutrients, and there's always a nutrients discharge from sewage treatment plants. There is a nutrient discharge, fertilizers from heavy rain, and that's why people need to change the way they do things. And in our discussion when we did the public meetings, I indicated, I said, you need to look at the change of the water cycle. If you have, he said, well, we do what my grandfather used to do. I said, if your father used to put it in September and the rain comes in November or October, that's okay because the land used the fertilizer. But if you put it in September and the heavy rain comes in September, it's a loss for you because you lost the fertilizer and it goes also in the lake. And that's what happened in Lake Erie in 2014. It was heavy fertilizers and indicated the kind and where it came from. And now with the DNA testing and all these things, they can find the source of that. So it was mainly fertilizers.
Okay.
Okay.
Well, friends, I think that takes us well beyond our time. And we would like to thank Professor JASIM for spending the afternoon with us. And we'd like to
It's a
thank
great pleasure to be with you guys.
um, Valerie for finding you again for us at short notice. And I think that was a stimulating scientific presentation, which I'm sure the operators who are participating here this afternoon or following this webinar
Yeah,
will
and
be
I'm more
able
than
to.
happy to answer questions if people have any emails. I could send them the studies if they like to see it. I'll be more than happy to do that.
Right. Thank you very much for that.
My pleasure.
So, okay, folks, this is the end of our webinar number 9. I'm Ignacio Ja, the Caribbean Water and Sewage Association, signing off. And also, just be reminded that we are not going to have a webinar next Wednesday. For circumstances beyond my control, I have to be on some other assignments. So we will resume in, I think, the first week in May. Right, Valerie?
Yep, I think that's right. You've got the schedule.
Okay. Bye, everyone.
Right,
Thank you.
thanks. Thank you,
Thank
Saad.
you. Oh, my pleasure. Thank you.
Bye.